So I'm the first speaking today. We have 3 presentations in total. I'm going to share my screen. So first of all, let me introduce myself, even if I guess that you know me already from GIS for Schools. I'm Daniela Carion from Politecnico di Milano. The idea of today's webinar is to introduce you to applications of what you have studied throughout the project. And to see which are other projects that we are involved or other possible applications that could benefit of this knowledge. So the project I'm going to talk about is called Simile and regards lake water quality monitoring with different techniques, as you will see. In particular, I'm going to focus on remote sensing and citizen science. So what is Simile? Simile is the acronym for Informative System for the Integrated Monitoring of Insubric Lakes and their ecosystems. It is a project which is funded by the Italy-Switzerland project. Sorry, I forgot to say something. As you can see here, there are many names, and actually if I had put all names of people who are involved in this project, the list will be much longer, because this is a large project and this is only part of the team from Politecnico di Milano. There are lots of contributors also from the other partners that you see the logos around the slides. So this is a large project which started in 2019. This is a project which is funded, as I said, by Interreg project, which aims the Interreg program, which aims at fostering the cooperation at borders between countries. So in this case, it is the border between Switzerland and Italy. The idea is to foster, in this case, the administration of waters of lakes that are across the borders of these two countries. In particular, you see here the 3 major lakes which are involved in the project, which are Lake Maggiore, Lake Lugano, and Lake Como, which are 3 large lakes in the northern of Italy and partly in Switzerland. So the project is going to involve different technology in an innovative way. So from the one side, we have sort of standard technologies which are used in an innovative way, because we have in situ sensors that are mounted on buoys that are staying within the water permanently, and which are sending information about the parameters that are measured for knowing the water quality on a very high frequency. So in some cases, the data are acquired every second. So we have really lots of measures. The point is to have a continuous monitoring, which is done in real time. Of course, this monitoring cannot be very much spread around the lakes. As you can see, the lakes are quite large. So for every lake, we have from 1 to 3 buoys which are acquiring data. So very precise information with very high temporal resolution, but of course on limited positions. Then starting from the data that are acquired, also a large part is related to ecological modeling, which is not something we are involved directly in. Then we have other technologies for acquiring information, which are remote sensing on one side, in order to produce maps of water quality parameters based on satellite imagery. And on the other side, we have the involvement of citizens. With a mobile application which has been developed on purpose for this project, with the aim of involving the population and to complement the measurements that can be done with the other techniques. Because I said in situ sensor, very precise, but on limited positions. We have the satellite images which are covering on the opposite all surfaces of lakes. With a certain temporal resolution, so every 2 weeks or every month, as we will see, depending on the sensor. And then we have citizen science, which can be very much related to when and where a phenomenon is monitored, or if we have contributors who could be, for example, people who live the lake, like fishermen, or people who go there for leisure, who could contribute with measures that are made at other instances which are different from the ones of the in situ sensors and the satellite images. In addition to this, we have web services which are designed in order to share the data of these sensors, and also a business intelligence platform which is aimed at collecting all of this data together and allowing citizens and stakeholders to explore the data and to be able to take decisions based on this data. In this presentation, I'm going to focus in particular on satellite-based maps, web services based on this, and citizen science. So let's start with remote sensing of water quality parameters. I hope, are now little experts about Earth observation thanks of the course of GIS for schools, but let's just recall very fast the very basic concepts that we are going to apply. So the fact that thanks to the energy which is coming from the sun, which is reflected by the Earth and partially emitted by the Earth, we can collect information on satellite images. These images can provide us information of the spectral signature, which is how surfaces reflect the light which is coming from the sun. And depending on the wavelength, so depending on the portion of the spectrum that we are going to explore, surfaces interact in a different way with this energy. And so the percentage of reflection can be different. Here we see the spectral signature of vegetation, in which we have a peak in green light, and this is why we see vegetation as green. But as we can see, with the remote sensing, we can explore also something else, which is not what only we see with our eyes, but for example, infrared wavelength, for which vegetation has even higher reflection. So if with satellites, we can explore also that. So we are able to gather more information with respect to what we could with our eyes. So thanks to this, thanks to the satellite images which are acquired from remote sensing, after appropriate processing, we can produce maps of water quality parameters. Here you see maps which are produced for chlorophyll, total suspended matter, and temperature. These are the parameters that are explored in Simile project regarding lake water quality. Just another slide to recall some concepts. So here you see, again, linked to spectral signature, and in this case, linked to the property of water, we can see that depending on the wavelength, the radiation can penetrate more or less into the water. So depending on the portion of the spectrum that we are exploring, we can see only what happens on the surface, or maybe what happens a bit lower, deep in the surface. And the depth that we can reach depends on many factors. Here you see a list of what is that influences and what we can explore with remote sensing regarding water. So you can have suspended or dissolved matter. You can see sometimes the characteristics of the bottom of the lake in this case, but of course also this depends on the water depth and on the water characteristics, on water transparency and so on. You can have information about the surface characteristics. You can, if the water is completely flat or if it has different texture, or depending also on the illumination conditions, also the light could influence the way that you retrieve data. So many factors have to be taken into account, and also observation geometry. So basically how the sensor is oriented with respect to the sun orientation and the water characteristics, as I said. In addition to this, we have, of course, environmental conditions. So just to tell you that this is not a trivial matter, you need to know very much the sensor characteristics, the water characteristics, what we are looking for in order to be able to produce the maps. However, in And here you see the visible light, which is only a small portion with respect to all wavelengths that we could explore. I was saying that I said that it's quite complex, but in similar project, we produced software and algorithms that can be used also by not so expert users, provided that they have at least a basic training about these topics, and so that they know exactly what they are doing. Here you see a short list of satellite sensors that can be used for this purpose. In particular, these are the sensors that are used by similar projects. All of these provide satellite imagery for free, as you could see also in the framework of GIS for School project. So we have Landsat 8. In this case, it is used to retrieve temperature, and it has a revisiting time of about 16 days and a spatial resolution of 30 meters. Then we have the Sentinels from the European Space Agency. They as well are free. And we use mainly Sentinel-3, which has a low resolution of 300 meters. Here you can see how the different resolutions look like. So you can see how different the same object can look with respect to the different resolutions. And this requires, again, a bit of experience in handling the products. So mainly we use Sentinel-3 because of course, it has a lower resolution from, let's say, a geometrical point of view. But what is really relevant is that this sensor has been designed specifically to retrieve water characteristics. So the spectral bands that you see are quite many, allow to retrieve better certain characteristics. And then we have the Sentinel-2, which has higher resolution with respect to Sentinel-3, which is still good for retrieving such information. But anyways, the first option is Sentinel-3, also for revisiting time. As you can see, the Sentinel-3 has a very high revisiting time. Here you can see an example of products that have been developed in the framework of similar project. Here you see how many maps we have produced so far. As I told you, the project started in 2019. We are almost close to the end of the project. We are going to deliver all these material that has been produced to the stakeholders that take care of the lake. So the project is going to end, but the activities of the project shouldn't end, in the sense that the monitoring will continue. It simply will be managed in a different way, because people from the public administrations or the research centers have been trained with respect to what has been developed in the project. So here you see the frequency with which we have produced the maps. So chlorophyll maps and total suspended solids maps have been produced at least weekly, and lake surface water temperature at least monthly. So we have produced already hundreds of maps that can be used for analyzing the behavior of the lakes across time. So it is possible to see if there are different behaviors from one year to another. So this is a large richness to have the availability of time series of data in order to explore the characteristics of the lakes. All is produced with open source software. In particular, we have used in this case NAP, that I think you have also explored in the framework of GIS for Schools, which is a software provided by a European Space Agency. So everything is replicable. This is the architecture of what we have produced for sharing the data through a web service. The aim of this slide is not to scare you, just to let you know that there is a lot of design behind every data sharing, and there are technologies that are needed to be known in order to do this. So what I would like to raise your attention to is the fact that to produce such tools, what you need to have is, on the one side, geospatial competencies, and on the other side, informatics competencies that go very much together. Of course, informatics experts can develop lots of software, but in this case, also knowledge about GIS and geospatial data is very relevant. When designing how to share the data, we need to take care about a lot of details. Here you see some indications about metadata. I think that during GIS for schools, you have in some way understood that apart from data, you need to know also details about this data. So every time that you share information, you need to share also details about this data. So, for example, one way that we decided to apply in order to share this data is to pay attention to how the names of the parameters maps were produced, so that out of the name of the file, you could already understand which was the reference system, which was the satellite used, which is the parameter that you are exploring, and which is the date when it was the original data were acquired, so that opening the map already, you have lots of information. And this is used also to load the proper metadata within the system that is used to share the maps. Here you can see screenshots of the web platform that has been developed for sharing satellite maps. So also in this case, we paid very much attention not only on the maps to be shown, but also on how to make it as much as possible interactive, clear, user-friendly, and to show all details that are needed, such as I said, the type of parameter that you are seeing, but also the satellite that is used. And so you can see here on your right side the metadata panel, in which you have details about the map, the satellite characteristics, and also, of course, the legend. And through this application, you can explore the maps. You can see the time series. You can see how parameters vary over time. So this is meant for everyone to explore this data, not only the stakeholders, but also citizens who are interested in details regarding the lakes. Here you can see a short animation on how things could be explored through the maps. You have a time slide to see how parameters vary over time. Okay. And that was all for the part regarding remote sensing of Simile project. Of course, later, if you have questions, I'm here to answer. Mobile application is what we developed in order to be able to share the data collection with citizens. So we have developed on purpose for Simile project this mobile application, which was meant again to be as much user-friendly as possible, to be self-explanatory so that people do not need specific training to use the map. Even if we designed a specific training, we trained the people who were involved in the project, we prepared a video that you could access at the end of the presentation in order to see how the application works. We are advertising this application as much as possible. We are having activities with schools, something like what happens for GIS for schools. We are going in schools here in Italy to let students and teachers know about this, to try to involve them in activities that could be of interest for the students, in order to let them know about the project, and also try to involve them in the data collection, which is for us very, very relevant. So what can you do with the mobile application? A user can, of course, localize himself on the map. This you are quite used to do also with other applications. Then a user can perform an observation, but also what is really relevant, to add many details to every observation. On the map, the user can see the acquisition data of other users, as well as his or hers. And also, we can use the application to advertise about initiatives or events that are organized locally, which could be cleaning events or something environmentally relevant with respect to the lake life. What is relevant again to say is that the system is free and open source. As EU is asking, we are producing everything with free and open source software. Here you see some screenshots from the application. This is the map screenshot in which you can see the lakes of interest and the acquisitions that can be shown on the map. Here you see a screenshot of the window for the dialogue regarding the presence of litters. And here you see another type of screenshot, which is an explanatory one. So we try to make the application as much user-friendly as possible, so you can access lots of details that explain what you're doing, what you can do, which types of tools you can use in order to answer properly to every request. In this case, you see the description of a disk of Secchi, which is a tool that is used to measure the transparency of water. This is with a rope, you can let the disk go down in the water, and you measure when it disappears and when it becomes again visible when dipping it into the water. And this provides a measure of the transparency of water. So this is something simple that can be done with a tool that could be even built on purpose, as we will see later. So also in this case, we have the design of the mobile application. Here you see the technology that was used. The mobile application is available for everyone on Google Play and on iPhone as well. On the store, you can find them. These applications can be downloaded from everywhere, and you can acquire data from everywhere. Unfortunately, what we decided to do is to make the data visible only for the lakes of interest, just because this is the aim of the project, and also because if someone takes information out of this area, this is something that can be stored, that can be retrieved through the application that I'm about to show you in a few minutes, but it is not used in the framework of the project. So we wanted to be clear that the data that are going to be processed officially in the framework of the project are only the ones acquired along the three lakes. Also, in this case, as I was mentioning before, if you want to let's say the developer of this work, you need for sure informatics competencies, but also spatial analysis. In this case, maybe the spatial analysis is less involved, but everyone who was working on this project had both competencies. The first type of observation that you can acquire with the mobile application is pictures. So, and this is very intuitive, and it's also very relevant. So the idea to acquire, sorry. I think I need a second, sorry. Sorry for the inconvenience. So as I said, we can take pictures. These are very relevant because they provide very, let's say, easy interpretable information. As you can see, not all these pictures are, let's say, completely relevant to what we try to provide as indications in the application is to take pictures, trying to take also, for example, elements around the water in order to understand the scale of the problem that you are showing, to understand how large it is, which is the size of the elements that are floating in the water and so on. So this is the first type of observation that we acquire, but it's not the only one. We can have other parameters such as weather, which is at first automatically taken from a web service, but also the user can refine these details in case, and this is relevant because, you know, the color of the sky can affect the appearance of water, and temperature can be also relevant, and other details. Then there are several details which could be very relevant, such as algae, foam, soil stains, litters, odors, drains, and also fauna that could be present, which can be added. And as I said, for all of these, there are explanations with indications on how to do it. In case that the users can and they have eventually possibly tools for doing it, we have also the possibility to take measures like transparency with a Secchi disc, or temperature if they have a thermometer, not necessarily a professional one, but also pH or oxygen and so on. And then we have an open field in case that the user wants to add additional information. I'm about to end. I think maybe I hope I'm not running out of time. Then we have here details that you can get, and I wanted to show this picture, which shows Secchi discs that have been produced by students with recycled material. So one of the activities that we had with the students was to suggest them to build this with their teachers, and they then sent us back the pictures that they made with their tools. Some of them were fitting the purpose perfectly, others maybe less. But anyways, the idea was to provide good inputs for taking care and taking information regarding the lakes. The last thing that I want to show you is the web application that was used to manage the observation coming from citizen science, because the stakeholders have to manage this data in order to take care of the lake and take actions regarding what phenomena that could be of interest. Also, in this case, the application was designed on purpose for the project. And from this application, you can do many things. You can see the maps of the observations. You can go through the observations. You can delete them in case that they are not relevant, or you can group them. You can also see maps or see all pictures that were acquired. And you can as well compute statistics about the number of observations, about the details that are provided, so that the stakeholders can explore this data in easily and in an effective way. All these tools are open, and as I said, are open to everyone. In fact, at the end of the presentation, you will find the links to access them. Here you see the business intelligence platform, let's say design, but very, very general. This is the final step of the project, to be able to access all data from one, let's say, a platform, in order to have a general view of all that has been done within the project. So I thank you very much for your attention. Here you see some links from the project. I hope that you saw it at the beginning in the names, but it's relevant to mention that Professor Borbelli, who will speak in a minute, is the leader for the Italian part, the coordinator of the project. And so also her will be willing to answer your questions in case that you have some. And thank you very much.
Thank you, Daniela. I just have one question from the chat. Vanya is asking if you can share the links in the chat.
Sure.
Thank you.
Okay, I will copy and paste them in the chat.
Thank you very much.
Thank you.
Now I think
Meanwhile, we can go to the second presentation. The second presentation is given by Francesco Polinelli. So, Francesco, if you can share your screen, please.
Francesco, we can't hear you.
Okay, can you hear me now?
Yes, now we can.
Okay, sorry. Okay,
Thanks.
The setting was off. Okay, I'm going to share again my screen.
Thanks.
Okay, I hope you can see my screen and hear me well now. Okay,
Yes,
I'm going.
we do.
Okay, perfectly. Okay, I'm going to show you in a brief presentation what are the new trends in the Earth observation. So, if you want to answer the question, where is Earth observation going? We will cover 3 different topics today. The first one is nanosatellites. The second one is the Earth observation for agricultural purposes, and the last one is the role of artificial intelligence in the Earth observation. First of all, we are going to start with nanosatellite, but we want to answer the question, what is a nanosatellite? Nanosatellites are just satellites, small satellite with a mass between 1 to 10 kilograms. On the right, we can see the smallest nanosatellite, the so-called CubeSat, which is a satellite which has just 10 centimeter of dimension for each side of the satellite. Of course, we can have bigger and more advanced nanosatellite, and we can see in the lower part of the screen that the CubeSat can be piled up along one dimension to create bigger nanosatellites. The simple CubeSat is called 1U because that stands for 1 unity. We can have 2U, 3U, and so on. Up to 12U, I think, is the biggest nanosatellite. Here we can see a comparison between the standard satellite. In this example, we are talking about Landsat 8, is a very well-known and well-used satellite. And on the right, the nanosatellite. We can see that the mass is very different. We have thousands of kilograms for a standard satellite, while nanosatellites are under 10 kilograms. Also, the dimensions are very different. Satellites is many meters wide, while we just saw that nanosatellites are only a few centimeters. But the main, the most relevant difference is, of course, the cost of the missions. A satellite costs hundreds of millions of dollars. We can see that Landsat 8 cost $800 million, while nanosatellites are much cheaper. With just $1 million, it's possible to develop a nanosatellite mission. And another important difference is that to launch a satellite, because it's big, we need a dedicated launch mission, while to launch a nanosatellite, we can use other mission and have the nanosatellites just as secondary payloads. Here we can see some of the many missions around the world that are developing and launching nanosatellite. NASA launched 85 CubeSat since 2010, and 35 more are under development, and will be launched in the future. The European Space Agency has developed a hyperspectral CubeSat with a 3U, so 3 CubeSat piled up together to create a single nanosatellite with a hyperspectral sensor. Moreover, there is a 6-unit CubeSat that has a microwave and multispectral sensor with a resolution of 40 meters, and this nanosatellite is used mainly to analyze the polar regions. Planet is a private company, is the most involved until now in this sector, and it already launched the 120 3U CubeSat. Is pretty much the leader in the sector. But maybe the most ambitious mission is the Sat Revolution, is a real-time Earth observation constellation that is programming to launch up to 1,000 nanosatellites until 2026. There are going to be 6-unit CubeSat, and thanks to this huge amount of satellites, we will be able to reach a revisit time of 30 minutes. This means that each area of the world we will cover with an image every 30 minutes from this constellation. Those are just the main mission, but there are many others. For example, a lot of African countries are developing their nanosatellite missions. Here we can see the evolution of the nanosatellites through the year. We can see that in the last decades, they really exploded. There's been a huge increase in nanosatellite missions. These studies from a few years ago, so is forecasting for the next year 600 nanosatellite launches. While just a decade ago, there were just 10 maybe nanosatellite launched per year. So nanosatellites are becoming very popular. And the main reason, as we already told, is the cost. The cost reduction allows university, private companies, and the country outside the mainstream space agency to implement space missions. This effect has been called space democratization because, in fact, it's really giving opportunities to other countries and private companies to have their own satellites. In the future, the private sector is the one that is supposed to lead this evolution, and it's supposed to reach the minute coverage time resolution. As I told you just a moment ago, this means that we will have an image for each area of the world every 1 minute. It's very a huge improvement on this side. And of course, this high temporal resolution will be very useful to deliver fast, continuous, and real-time cloud-free observation. As you know, not every image we receive from satellites is useful because maybe there are clouds. So having many images is very important to be sure to have the data that we need when we need them. The next chapter we are going to talk about is the agriculture, the role of Earth observation for agriculture. And because we know that due to climate change, new crop varieties, the farm getting bigger, and new scientific insight, the agriculture sector has changed over the last decades. But also the world is changing, the population is growing, it will be keep growing in the future. So we need a sustainable and resilient agricultural system to ensure food security for everyone in this world. Earth observation is becoming extremely helpful in this, proving to be successful in achieving this goal. We can see some application of Earth observation for agriculture. First of all, thanks to Earth observation, we can estimate the sown areas. So we can, from satellite sensor, we can map and measure the area of a planted region. And these numbers, this knowledge can help in evaluate the risk and losses in the event of natural disaster. Moreover, we can analyze from satellites the crop status. Earth observation provides information that can be used to understand if the plant are under stress and therefore if they need more water or nutrient to improve their health. We can achieve this with NDVI or other vegetation indexes, and these information are very useful for a farmer that can act in consequence of this knowledge. They can know where in their farm the crops need maybe more water or more nutrient, and they can provide them using this information. Moreover, we can identify crop disease. Remote sensing makes it easier to identify contamination and pest attacks in large farmed areas at early stages. Of course, an early alarm and being able to spot in the early stages these pest attacks allows the producer to take measures to protect the harvest from huge losses. Of course, here you see an image of an insect. Of course, from satellite we cannot see insects, but we can see their effect. We can see if vegetation is suffering, if it is losing their mass or their vigor. And so we cannot see the insect, but from satellite we can see in a similar way to the image we saw in the slide in the previous slide, if the vegetation is suffering and take measure to act against it. Moreover, from satellite we can also analyze soil properties. soil salinity, soil pH, organic substance level, and soil texture, and moreover, soil moisture can be recognized using remote sensing detection. The data can be analyzed to carry out significant soil treatment. So also we cannot also see vegetation, but also the soil, analyze the soil, and maybe take treatment to improve the quality of the soil where we are going to farm. One of the main reasons, again, why Earth observation is becoming so used in agriculture is the growth of remote sensing data availability that occurred over the last decade. Satellite with a high temporal spectral and spatial resolution like Sentinel-2 sensor or hyperspectral precursor and application measure like Prisma allow for new or improved agricultural application. Moreover, as we talked before, the advent of nanosatellites further improves the revisit times and spatial resolution of satellite system. We can see in this image how many satellites are orbiting around Earth. Of course, this is not the true size of satellites. They are much smaller than we can see in this image, but it really helps to give us an idea of how many satellites are orbiting around our planet. But as we saw until now, there are many data that are coming from satellites. So we need some help to analyze those data and to deal with them. Artificial intelligence is the solution maybe to solve this problem, because data coming from satellite are rapidly increasing, and we need faster, reliable algorithms to deal with this huge amount of data. Therefore, artificial intelligence and machine learning algorithms are coming to help us. What is artificial intelligence? Artificial intelligence is the theory and development of a computer system able to perform tasks normally requiring human intelligence, such as visual perception, speech recognition, decision making, and translation between languages. Of course, we are more interested in visual perception and decision making for Earth observation. Here we are going to see just 3 small examples of artificial intelligence used in the Earth observation field. The first one is applied to nanosatellites. One of the main challenges that nanosatellites present is how to deal with the large amount of data that they will provide you. If we think about receiving every minute an image from every area of the world, you can imagine that this is a lot of data that we need to deal with. So to address this problem, the European Space Agency introduced the first artificial intelligence on board a satellite. So on the FSS-CAT mission, there is an artificial intelligence on board the satellites, the FISAT-1. This artificial intelligence is capable of its own to identify clouds in the images. And therefore, the images that are too cloudy are discarded and not even transmitted to Earth. And this is a first step to reduce the amount of useless data that we are receiving from nanosatellites. Another example is the use of artificial intelligence in the agriculture field. Remote sensing data processed with artificial intelligence and machine learning tools can help farmers to conduct crop forecasting and manage their agricultural production. The data are collected and processed to provide NDVI and many other vegetation indices. We already saw these images to identify crop stress, waterlogging, and manage production yields to entry grading. The ability of artificial intelligence and GIS to analyze and visualize agricultural environments and workflows has proven to be very beneficial to those involved in the farming and the agricultural industry. But maybe a different field that is not the most known is artificial intelligence is also useful for wildlife conservation. It takes advantages of machine learning and computer vision models. Using imagery collected by satellites or UAV drones, we can predict behavior and provide near real-time reports of repetitive attacks by poachers that will assist anti-poaching teams in catching the offenders. So this state-of-the-art technologies using this modern algorithm of artificial intelligence and machine learning, scientists are able to help conservationists to decrease illegal activities such as attacks on wildlife and therefore protect them and protect natural resources. So we can conclude saying that artificial intelligence and remote sensing can create computer vision models to better understand the data we receive from satellites. These models can provide near real-time reports for large-scale science areas with complex feature distributions, such as in the application of agriculture, we saw them, urban planning, transportation, disaster management, climate change, and also wildlife conservation. Artificial intelligence can aid in data collection, processing, and understanding using neural network and deep learning through computer vision models to allow data users to better understand and handle data more efficiently in a timely manner. So this is pretty much my presentation. It has been maybe really short, but I just wanted to show you where is Earth observation going, what is new in this field, and I hope you enjoyed it.
I-am două ciocuri care alea trebuie să ne le trateze.
Thank you, Francesco, for this very clear, informative presentation. We will ask students or professors as well if they have questions in the end, in such a way that I conclude with my presentation, and then we give the words to them. Anyway, thank you a lot for your presentation, as well as the presentation of Daniela was very, both of them were very, very interesting. Okay, I go to my presentation now, sharing my screen, and yeah, I hope that you can see it. So first of all, I want to start thanking Eurizi for helping in the organization of this webinar, all the students here, and also the speakers before. So my presentation will in some way conclude this webinar, and the main point is why we, or better you, are interested in these topics. So I want to show you which are the opportunities for you. So why geoinformatics and Earth observation matters for us. Okay, so let us consider from that point of view, which are the perspective for your career and your future job. So I want to start looking at what was the situation some years ago, which are a lot of years ago, but as a matter of fact, not in the archaeological time. So we can see the first picture, which is a picture from of Paris, a picture of Paris that was taken by this guy here, who will made picture from the hot air balloon, and you can see that the year was 1858. So under 50 years ago, we can say, more or less. And those were the first pictures taken from Paris at that time. Then, as relevant step, we can consider the this experiment of the Wright brothers when we had the first airplane flying. And you see here it was under 20 years ago. But then in 1957, so at this point, 70 years ago, we can say, we had the first artificial satellite, which is the Sputnik. I don't ask you because I imagine that all of you knows that the Sputnik was the, oh, sorry for that, What happened here? The Sputnik was the first satellite. And here, the last picture, you can see the first picture taken from the space. And it is a portion of Pacific Ocean covered by clouds. Obviously, you see here that the quality of this picture is definitely worse than the quality of this image that was taken by Nadar on the hot air balloon. But let's go ahead and see what's happening now. So this was the photo taken by Nadar. And what you can see on the right is a satellite image. So this is an image of Paris, the same place, taken from a satellite, because now we have satellites that are able of collecting images with a resolution of, the best resolution is 30 centimeters around. And this is not a technical limit. This is due to some agreement related to privacy, as a matter of fact, and other reasons, but is not a technical problem. So probably, or for sure, there can be some military images which are also higher resolution. We don't know, as a matter of fact, because we are not involved in that field. Anyway, this is what we can get from satellites today. But the point is, as you already saw in the previous presentations, the point is that we are not only able of visualizing the data, but so looking at the data, looking at the picture, but due to the typologies of sensors that are on the satellites, we are able of analyzing most of the phenomena happening on the surface of the Earth. You can see here, starting from the magnetic field, but also the snow, the sea salinity, and you saw some examples in the previous presentation. And we have sensors which are able of taking pictures, but we have also sensors like, for instance, I want to mention again, because it was already mentioned before by Dr. Polinelli, this satellite, which is called Prisma. This is an Italian satellite, and this is characterized to be hyperspectral. So it means that we can see much more portions of the wavelength spectrum. Also, we can see where our eyes can't see. And just to recall you, you have seen already this picture on the book that we provided to you for studying those topics. And this is what we can see in the visible part of the spectrum, but this is what we can't see with our eyes, because as a matter of fact, you need to have special eyes able of capturing the infrared part of the spectrum. And the humans are not able of doing that, but there are other animals that are able of doing that. And the sensors which are on board of the satellite are able also of managing this kind of data. So we have a sort of augmented eyes for analyzing what's happening around. Okay, and with respect to sensors, we can say, it was already mentioned, but I want to go back again to this concept. We have sensors everywhere on the ground or moving on the surface of the Earth. You see here some typologies of sensors, and those sensors are a sort of sensitive skin of the Earth, monitoring continuously the status of the Earth. And At the same time, we have, as we saw, satellites also monitoring the surface of the Earth. And I want specifically to remind again the Sentinels satellites, because those are the satellites of the European Commissions, and together those satellites, the Sentinels and the sensors on the ground, are providing within these, in the frame of this wonderful initiative, which is the Copernicus initiative, they are providing open data which can be reused by everyone, which can be reused by experts, but which can be reused by all people who are interested. And this is opening tons of opportunities. Specifically, if we look at the political initiatives of Europe, we can pay attention to three relevant initiatives. The first one is the one that probably all of you know, which is the European Green Deal. So we want to be the first climate neutral continent, and this is what we want as Europe. The second relevant initiative of, I didn't mention the year, so very recent, 2019, but 2020 European Data Strategy. So we want to reach that, having the possibility of exploiting all the data that are available, and among them, very relevant, those data I mentioned before, the Copernicus data. And the last initiative that I want to mention is the initiative of shaping Europe's digital future. Again, using the digital data, try to build something that can be useful for this big project, which is called the Destination Earth. So what is the destination we want to reserve to our Earth? And what is this Destination Earth, or what is one of the relevant aspects of the Destination Earth? What is one of the relevant bases of the Destination Earth? So Destination Earth aims to develop a high precision digital model of the Earth for doing what? For modeling, monitoring, and simulating natural phenomena and related activities. So this is what we want to do. We need to have a tool, which is a very important tool, helping us in monitoring, but also simulating what can happen depending on the decision that we will make with respect to our Earth. And what are the main components of this Destination Earth, or what is more related to what you saw in the training that you attended and your professor started explaining you and so on? What are the main ingredients that we can consider? The first ingredients are data. And we know, with respect to the data, that we have available Earth observation data from Copernicus, both from the ground and from the sky. We know that we can use the Internet of Things. That means connecting among them all the sensors. And there is another point which is relevant and was presented by Professor Carrion, which are the data contributed by citizens, so what is called citizen science. And I will come back again to this concept. Then the second relevant aspect is the aspect of the cloud-based federated platforms. So we are going toward the building. Some already exist, but they will be improved and becoming more and more. Those platforms for modeling, simulating, and predicting what's happening on the surface of the Earth. And then the last step is the creation of what are called the digital twins Earth. So digital replica of the Earth, but I'm using the plural because really it depends on what we want to focus on. The two examples that will be built in a very short time, as a matter of fact, they are already being built, are the two digital twins related to the extreme weather and geophysical events. So for disaster risk management in relation to natural disaster induced by extreme weather conditions, and we know how relevant they are becoming. And the second one, which is the digital twin for the adaptation to the climate change. So this is very relevant mainly for food and water supply security. So something that you saw in the previous presentation, the first one focusing on water, because water is very relevant for our life, for the life of on the earth, and on the other side, food, because we have to feed a big amount of humans which are living with us on our planet. And then starting from that, being able of building many other applications, because this is the first product, but once we have these digital twins, we will be in condition of developing other value-added services to and from public and the private sector that can be based on that, but obtaining something different, something new that we can think about. Okay, and already Dr. Polinelli explained what is artificial intelligence or machine learning and how it is already used in some cases. You have to consider that this will be used in every field, as a matter of fact. So the general idea of this digital twin Earth is to have a physical world, which is the planet Earth, and having this continuous stream of observations coming from the physical world, adding the possibility of processing this big amount of data. Machine learning can help. I can say that also the traditional statistics can help it, but we have these new tools, which are the tools related to machine learning. And so starting from observations, starting from the laws of the physics, because we have to remember that we want to have something that is physical based and using traditional statistics, but using also machine learning, obtaining the simulation of what's happening on the surface of the Earth, not only on the surface, what's happening on our planet. Okay, so this is where we are going toward. We are going toward revisiting the past, understanding and building the present, and predicting the future. And these technologies that were presented before are exactly the technologies that we need for building these digital twin Earths so relevant for the destination Earth. But I want also to touch another point, and specifically, I want to open a window for you. And I want to open a window, recalling the situation about another example, the example of the global positioning system or the global navigation satellite system. that probably you know, because I imagine that all of you have a mobile phone, and in your mobile phone there is a chipset for acquiring data from the global navigation satellite system. Okay, and all these stories started, you can see, in 1973. We had the first constellation of satellites providing the possibility of locating ourselves on the surface of the Earth. And in the beginning, this was a military project. In the beginning, it was developed by the Department of the Defense of the United States. And using this technology, it is possible to define where we are with an accuracy that it's really surprising. Now, you can say that independently of the chipset that there is in your mobile phone, you can locate yourself for sure with an accuracy of less than 10 meters. Obviously, there are some chipsets that are better. We can say also 1 meter, but at least let us say 10 meters. Okay, in the past was a nightmare for determining where I was with the same accuracy. It required a lot of time, days of measurements. Now it's just a matter of few seconds, less than seconds, for checking where I am with this accuracy of at least 10 meters. And this is very relevant. This changed things a lot. So in the beginning, it was studied as a military project, but then we are using now that it was open to everyone, also for the commercial use, we are using it for navigating. All of us, we are using for navigating both with cars and individual navigation. But again, we are using it and we will use it for the self-driving vehicles. And at that time, in 1973, nobody was thinking about this application. But we mentioned it before, citizen science, and so we can use it also in citizen science. What is citizen science? Citizen science means that citizens help scientists in making their research. In the best case, citizens not only help providing data, but they help also providing ideas or co-creating with scientists new projects, new things to discover, and so on. So starting from the what we know that was the traditional citizen science, for instance, the bird watching, now we have these new applications, that the application that Professor Carrion presented you before. So the application for checking the quality of the ecological quality of the water of the lakes. And this is just an example, because you can consider tons of examples where we reuse the location for providing pieces of information about the state of the environment. And this is very, very relevant. Other examples that are more general are examples, for instance, these examples related to humanitarian projects, or other examples like this one that I want to mention, related to how to use these technologies for improving the lives of women in everywhere, but specifically this project was in Latin America, or these other projects using again citizen science, location, satellite data for fighting against female infibulation in Africa. So you see how relevant are those examples, because at this point, I want also to reason with you about one point that, in my opinion, is very relevant. We saw that there are many opportunities, self-driving cars, starting from the self-driving cars, going to making better the life of women on the surface of the earth, and so on and so on. So once we are aware of all the important opportunities we have, we need to be very clever also in using the technologies for making this world better, because you see that the situation is not a good situation. So it means that we were not so able of using the technologies for making our world better. So I want to discuss with you also with respect to this point, what can we do for making this world better? Because we need to be responsible people and not to deteriorate and make our world a world of destruction and waste. So how it is possible to start reasoning about that? Oh, there is something that we can use. There is a metric that we can use. And this metric was the metric suggested by the United Nations. And though these metrics is a metrics based on the Sustainable Development Goals. I don't know if you know the Sustainable Development Goals, but if you don't, I encourage you in looking at these relevant targets and indicators, helping us in doing what is called science and technology for good. So if I want to summarize just with few words, science and technology for good, the main message is leave no one and no place behind. So we have to do everything for all the people and all the places in the world. So pay attention on that. Be a responsible person. Probably we were not so responsible, as a matter of fact, because we are giving you a word that is not so good, but the main message is please pay attention to that. The wonderful technologies, we have to use them for good and not for making this world worse. Then let's come to the opportunities. So this field is growing in a very relevant way. So you can see that the annual increase in the GIS related jobs between 2020 and 2030 is supposed to be 12%, and the annual increase in remote sensing related jobs, Earth observation, again. So it means that there are many opportunities for you because it's something growing in attention. And so there are many opportunities related to geoinformatics and Earth observation. And with respect to that, obviously, depending on what you are more interested, you can think of becoming a researcher, a teacher, or working in the private sector as a technologist and so on. So really, there are many opportunities. It's full of opportunities. You have only to choose. But if you say, I'm not so interested in becoming a scientist or a technological person, in any case, you can consider, if you are more interested in humanities, you can consider that nowadays, also in these fields, these technologies are becoming very relevant. Like, for instance, suppose that you say, I want to become an archaeologist, so not necessarily an expert on Earth observation. But if you want to become, for instance, an archaeologist, pay attention that many many discoveries were made using these satellites imaging and using geoinformatics. And so pay attention to the fact that those technologies will be relevant with you independently of the fact that you will decide to go toward this direction or doing something that is more social, cultural, and toward humanities, because in any case, you can reuse something relevant starting from which is derived from those scientific and technological aspects. Okay, but then if you say yes, but now you convince me. Yes, I want to deepen in more into this field. Okay, so you are lucky with respect to that because you already started being contaminated with these technologies as first students in Europe. As a matter of fact, you have all the material that was provided by us, the material that you are building also for other students in the other part of the world. But if you say, yes, I want to go ahead, absolutely. Please consider that there is the possibility of studying later on these topics also at the university. And obviously here I will present only the example of Politecnico di Milano because I'm professor here, you can see. I'm sponsored by Politecnico, and I will present what's happening at Politecnico, but obviously you can find something similar also in other universities. So at Politecnico di Milano, we have that at least 7 masters of the Politecnico, up to 33, have the possibility, have some courses related to these topics. And if you say, yes, but I'm absolutely interested in geoinformatics and Earth observation, please consider that at the Politecnico there is also one course of study, one master, which is specifically on these topics. That is called geoinformatics engineering. So there is the possibility of studying exactly what we are speaking about in this project. So this is the conclusion of my presentation, and therefore at this point I believe that we are ready. My colleagues and I, we are ready to your questions. Okay, so I don't know if there are questions.
For those who have questions, you can directly unmute yourself and speak.
I see people smiling. So are you ready to start working in this field? We have a first success because you don't know, but we convinced Elisa in becoming, so who is the leader of this project. In the beginning, she just knew something about Earth observation, but now she's so enthusiastic about it. Probably because she discovered that is something really relevant.
It's true. Even if I had no scientific background, but humanistic, as you said, I think that you can discover really the potential of these technologies, of the data, and how its concrete application can really, I'm not saying change the world, but help us in making the world better in a very concrete way. So, yeah. In this sense, I think that our students are lucky, as you said, because you had a great opportunity. But I will also join Maria in inviting you to interact with the professor, because the real great opportunity you have is also this interaction that you can have with your professor in schools, but also with the professors of the Polytechnic of Milan, which is one of the best university in Europe and in the world. So really take this opportunity for any questions or doubts or curiosity you have, because I would have one, but I will leave to you.
You can also use the chat and we will read the questions for you.
Okay.
So, yeah.
Yeah, because yes, the time is over. So,
yeah.
Elisa, if you want to make your question, we will answer quickly, and then we will leave.
Yeah. Okay. So very quickly. My question is about the digital twins, which, as you said, is one of the next frontiers of the next mission which we are engaged. My question is about the digital twin. We can, let's say, we can build a digital twin. Even, I mean, the digital twin has I mean, you can have a digital twin of, let's say, of our city, but I mean, a digital twin must have to focus. One is on the topic that you are going to analyze. You mentioned climate change in example, and the other one is the location, or we can have a digital twin of many different different locations.
Yeah,
and,
yeah, yes, it is not something that is already planned. My opinion is that probably the best is to have the local digital twins, starting from municipalities digital twins, and then a federation of digital twins. But this is just my idea, because I always prefer the bottom-up approach instead of the contrary. But probably there will be something which is general, like for instance the one related to climate, and the local digital twin can exploit the data made available there, adding also in their local digital twin other local data. So in my opinion, the best option will be a federation of digital twins, but it is not yet written. It is not yet written. We are really in the beginning of this one. The idea of digital twin or metaverse on the other side, that it's another name, a buzzword that is going around, but that will be realized in few years. And we are really in the beginning. You saw that the Destination Earth is a concept of 2 years ago. Yeah. Okay. Thank you. So at this point, if there are no more questions, what we can do is for sure to share our slides. So we will share the slides with all the students. And then on the slides, we will put also our email address in such a way that if you have curiosity in the future, questions in the future, you can write us and ask us. There is also this possibility. It's not this one the last occasion. So you can write us, and we are very willingly of answering to you every question you have. And that's all on my side. I don't know if Daniela and Francesco want to say hello as well. And then I leave Elisa concluding.
I would like to thank all for the opportunity, the attention. It's a pleasure to share with students what we do in our research.
Yes, of course. Thanks to everyone. And Good morning.
Elisa, last
Thank
words
you.
is yours.
Yeah, of course. Thanks, Maria. Thanks to all of the professors and also to the professor in the schools and to all of you. And yeah, as Maria said, it is definitely not the last opportunity to get in contact directly with us. But next webinar and next opportunity will be organized very soon. So thanks again and have a good day.
Thank you. Bye.
Ciao, ciao,
Bye.
ciao, ciao.